My name is Nur Alisha Zwa binti Muhammad Amran and my matrix ID is 2024437002.
Hi, my name is Darisha binti Hadi. My matrix number is 2024805714.
Hi, my name is Ashraf Haikal bin Muhammad Fikri and my matrix number is 2024263668.
Hai, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Daniel Hakim bin Rusli. My student ID 2024698234.
Linear motion refers to the movement of an object along a straight line in one dimension. In this type of motion, all points of the object move in the same direction and at the same speed, maintaining a constant orientation. The characteristic of linear motion is the object travels along a straight path. The direction motion occurs in one direction, forward or backward. The motion can be uniform if the object travels with constant speed and non-uniform because of the speed of the object changes over time. For an example that we can use in linear motion is a car moving on a straight road, a ball dropped vertically under gravity, and a train moving along a straight track. Thus, linear motion is one of the simplest forms of motion and is often studied in physics to understand basic kinematics and dynamics.
The objective of this experiment is to investigate the relationship between force, mass, and acceleration and to determine the acceleration of an object under a varying force.
The material that we use is air trade rail, blower, pressure tube, gliders, flag, photo gates, messes, mess hanger, string and pulley.
The first step for this experiment is the linear air was assembled. After that, the pump was switched on and air was allowed to blow through the track for several minutes. The track was balanced by adjusting the screw on the legs of the track so that the glider remains stationary and does not glide to either end when released. The third step is one hook was inserted at one end and a flag was placed on top of the glider. Next, the mass of the hanger and the mass of the glider was measured and recorded. The length of the flag was then measured. After that, one end of the string was attached to the hanger and the other end was attached to the glider.
The mass with a mass of 20 grams were placed on the hanger and 80 grams were placed on the glider. The string was put over the pulley. The glider was positioned exactly before the photo gate. The glider was released and the time shown on the photo gate was recorded. The process was repeated 2 more times to obtain the average time values. Then the slot mass of the glider was decreased by transferring a mass of 20 grams onto the hanger. The procedure in step number 7 and number 8 is repeated. The procedure was repeated 3 more times, with 20 grams from the slot mass on the glider added to the hanger.
Analysis 2. What does the graph tells us? Based on the graph, the second law of motion states that an external force accelerates an object. We could tell that the force F is directly proportional to acceleration A. When the force increases, the acceleration will also increase. This indicated that if mass is constant, then force equals mass multiplied by acceleration.
Question 3 is determine the gradient of the graph. I am using the formula m equals to y2 minus y1 over x2 minus x1. The first coordinate is 0.37 and 0.2. while the second coordinate is 0.82 and 1.7. Therefore, 1.7 minus 0.2 over 0.82 minus 0.37 equals to 3.33 meter per second squared.
Analysis 4. The uncertainties of gradient m is 3.33 plus minus 0.3845 meter per second.
For the analysis number 5, briefly explain the relationship between the gradient from the graph and the total mass mt equal to mt1 plus mt2. So the graph shows a linear relationship between acceleration and force. The gradient of this graph represents the inverse of the total mass of the system. This directly reflects Newton's second law of motion. Force equal to mass times acceleration, which can be rearranged to acceleration equal to 1 over mt times force. So the steeper the gradients, the smaller the total mass, and vice versa. The graph confirms the direct proportionality between force and acceleration when mass is held constant.
After using a formula to calculate percentage error, the answer that we obtain is 10.14%. Thus, for percentage difference, the value that we obtain is 1.67%.
The second question is, discuss the factors that have contributed to the errors in the experiment. The first one is, the air resistance may interrupt the acceleration of the slotted mass and may affect the time taken for the glider to pass through the photo gate. The second one is, manual reading or estimating in measurements could lead to minor error that accumulate.
For the question number 3, explain how to overcome the factors mentioned in discussion number 2. So the first one, streamlining. Use a glider with a more aerodynamic shape. This reduces the surface area and exposes to air resistance. The second one, smooth track. Ensure the glider move on is clean, level, and smooth to minimize friction and any additional resistance. The last but not least, multiple trials and averaging. Repeating each measurement multiple times and calculating the average helps to reduce the impact of random errors. The more trials, the more reliable the average.
From the experiment and the result obtained, the total acceleration obtained after the calculation is 3.33 ms2. From the result, a graph also can be drawn to determine the gradient and the uncertainty of the gradient. The gradient that obtained is 3.33 ms2. The max value is 0.847 ms2 and the minimum value is 0.078 ms2. After using a formula, the uncertainty value that is found, which is 0.3845. The full complete value can be written as gradients equal to 3.33 plus minus 0.3845 ms2.